Hello everyone, my name is Ahmed and my team is a participant in MIE competition under the username of BENHA-EP-7-01 and our project is fully automated production and assembly line utilizing robots. But before I talk about the details of the production line, I want to say something worth mentioning first. All of us have the dream of seeing a product fully designed and manufactured here in Egypt. And of course, that is why we are recording this video from the first place. Lots of us has a previous bad experience, especially if you are an engineer, a software developer, or a researcher. After you finished your prototype, you've headed to a lot of companies trying to convince them to manufacture your prototype. But some of us ended up frustrated, and that might be because lots of companies has fears of investing in technology, and they say investing in services is much safer. We're about to change that. Our idea is instead of wasting the rest of our efforts trying to design another end user type of product, we wanted to put our efforts into the heart of industry itself. And I mean by that the machines, tools, or any other parts that is required in the manufacturing process. And those machines would be something like CNC machines, smart controlled conveyors, and of course the most competitive machine among them, robots. So that was pretty much the description of our graduation project. So our project is going to be an assembly and a production line that is going to use two robotic arms. One of them is going to be handling robot. Handling means moving some work piece from a place to another. And this robot is going to be responsible for the assembly and packing tasks of the line. The other one is going to be a task-oriented robotic arm, depending on the end effector the robot is going to be equipped with, and this robot will determine the overall task of the line. We're still waiting to listen to our sponsors' needs to determine which task this robot is going to be assigned to do. Still, we are going to use a conveyor to move products between the stages of the line. So if we want to make such a project come true, your team have to cover all the fields of mechanics, electronics, control, and computer science. Our electrical team can cover all of those fields except mechanics. That is why we joined mechanics team back in our college. But your rules forbid this action except you get a permission from the committee of MIE. So that we decided to go to the competition into two separate teams. So for the electronics team, we formed that team by choosing the best in designing or who have the expertise in fields mentioned before. We divided ourselves into subgroups. Each member in the team is going to identify himself, then he's going to talk about the part he's interested in.
Hello again. Me and my friend are going to form the subgroup that's going to make what we'd like to call the robot spray. My name is Ahmed Ismail and my friend's name
Mohammed Nabil.
We will design the control circuit for this robotic arm.
This board is very critical. I will write the software to interface between main device.
And I would like to write the control algorithm, designing the user interface, what we would like to call the UI, and of course I might design the PCB for the controller of the robot. And I think that's it. Yes. Good luck and goodbye. Bye.
I am Islam Muhammad. My part is the power supplies and power systems such as converters, inverters, and anything that carries high voltage and currents.
ابدأ.
And here it come to me. First, my name is Mahmoud Saida. I'm the one who's responsible for the parts that necessary to move each joint, the muscles. As we see, joint 1 will rotate the arm, joint 2, joint 3, joint 4 will move the arm up and down and in the circle. I'm going to use a stepper motor. The stepper motor is electromechanical device which convert electrical pulses to mechanical movement. And I hope that will work.
My name is Mahmoud Said Ahmed and
Muhammad Ali Muhammad.
we will design the motor driver. The driver converts the microcontroller command signal into the power necessary to energize the motor windings. There are many types of driver with different current ampage ratings and construction technology.
Not all drives are suitable to run all motors. So when designing a motor control system, the drive selection is very critical.
So, We've listened to each group in the team, trying to explain their duties. Now at the end of this, I want to show you some of the projects I participated in previously related to the subject of this video. In 2009-2010, I designed the control circuit for the handling robotic arm shown in this picture. It was a graduation project for senior students in the industrial mechanics in our faculty, BENHA University. The design had suffered from some drawbacks both in mechanics and in electronics. In mechanics, the most dominant faults were the huge backlash in the base bearings, friction in gearboxes, and misengagement of the gears. In electronics, the motor drives were not able to give the motors the required power, so the output torque dropped. There were no algorithms for the automatic drive for the robotic arm, and the robot ended up like a manual lift. In 2010-2011, I had the chance to share my experience with a graduation project team from a mechatronics department in Ain University. The robot was stronger, and I enhanced especially the drive circuitry of the motor, but still no automatic movement algorithm. But the manual interface were improved using the ATBC keyboard with a bigger LCD and with the capability of changing the robot parameters. At the same year, apparently it was my lucky year, a factory from the Arab Organization for Industrialization, it is a military organization, asked us to design a handling robot to put in the gallery of the quality control department. The previous faults were not tolerated and the robot had to be featured with options of reprogramming the motion plan of the working envelope, and that is the path the robot will follow. We achieved this one, but it was incredibly slow. We are managing to solve that in our graduation project. Now I will let you see a video that will show you how this robot works. And remember, this project was asked to be developed for the factory of Qadr, Arab Organization for Industrialization. Here, the working envelope script is already finished, as you can see it on the list. Now I want to test it on the automatic mode. First, you have to select robot, motion plan, load a motion plan. First you should load this file. I've saved it under the name of tt.mpln. Open. Before pressing automatic move, you should select robot, motion plan, settings. These fields represent the number of trials the robot will perform before going to the end of the working envelope. I'm writing -t. That means the robot will work for infinite number of times. And the second field is the return path. Of course, we don't want the robot to return to its home position every time it finished one cycle. Pressing apply. Oh, this is the wrong value in the timing field. -t. Apply. Then OK. Then I press automatic move. You see the arm move automatically trying to reach its home position, the base home position, then the link number 1 home position and the link number 2 home position. The robot is moving to grabbing the payload, the empty soda can number 1. Here, trying placing it into its destination position on the chair. Now grabbing soda can number 2 back to the initial position as it was programmed on the script, the working envelope script. And continuously we'll try to move one can from a place to the adjacent place back to the workpiece into soda can number 2. So a mess.